Thank you, Matt, for that presentation just around the wood fiber board. And I think you'll see that a lot of what I'll be talking about is how B Public is really aimed at creating sort of a demand side for the use of both carbon measuring tools like pH ribbon, as well as demand side for sustainable fiber materials, and for lots of different reasons. So, but it will be referring to everybody's product in this process. So again, one thing that B Public is really centered on is trying to affect consumer decision making when it comes to decisions around construction approaches, both from a performance perspective, materials decisions, as well as processes for it, and really just trying to expose as much of the public as possible to best practices, and really trying to be pretty clear about what are really the opportunities that we have to affect positive change while doing business, right? So, and just a little bit about sort of my longevity, in this space. It was, I guess, over 20 years ago, we were designing passive solar buildings using compressed earth block with compressed straw panels on the exterior, rigid insulation, and simultaneously, I'll say those same buildings were using uninsulated floors. So that was before we were passive house trained, and we really in 2008 became trained, and then did our first passive house in 2009. We actually imported Augipon fiberboard for that project, and really did look at importing it, and it didn't work out economically for the time because of the challenges that Matt had talked about. And so again, I just want to reiterate our enthusiasm and support for what Matt is doing, and really excited to get him on manufacturing, and then also bring him out further west. And so B Public really works on sort of refining and optimizing the construction approach. We're a public benefit corporation with pretty clear bylaws to serve environmental responsibility and social equity. Those are two sort of mandates that we feel need to be addressed simultaneously and without sacrificing each other, both the development for housing and empowerment of rural communities, as well as really trying to mitigate climate change as quickly as possible. And as one of Matt's slides illustrated, I think even we can see that even if we achieve a site net zero performance level in our buildings, it's going to be insufficient to meet our climate goals. And so we really need to focus on trying to embed as much carbon as possible in those building materials while we develop. And so really, so the impact and performance, these are the three primary criteria that B Public uses to evaluate either materials, assemblies, and processes, or implementation. And impact and performance, very much related to we use the passive house approach and the PHPP as a best practice, and really one of the most successful evaluation tools when it comes to creating primarily energy conserving structures. And we're just so excited to have the pH ribbon now too, so that we can really have a lot more confidence in our carbon measuring and so forth. And a lot of our evaluation that we've done to date has been more empirical, and so it's really nice to be able to have that. I think, again, we're in a place where there's clear outcomes or directions for our decision making around performance. Okay, it's best to conserve energy has a significantly greater benefit over generating energy on site, period. So that's just we can sort of set that aside. When it comes to carbon sequestering, then using materials that have lower embodied values and higher carbon sequestering potential, that's a good thing. So we can just sort of, again, set that aside. We can analyze, I think, in far greater detail, some of the finer points and the tipping points between what materials are being selected, depending on the area or the application. But in general, we know that, bio-based materials are going to have a more or a reduced environmental impact, and so that's the direction we want to head. So, and again, so that's the kind of clarity that we're trying to convey to the consumers, and primarily in residential development. And the other portions of it, they're social and cultural. I think those are a little bit less tangible sometimes. A big portion of our staff have a focus on labor sustainability and workforce development and so forth. And so when we look at manufacturing or resource extraction and refinement and so forth, though, that's where social equity and community economics really come into play around our decision making. And then finally, in implementation, one thing that we saw sort of in the largest sort of underserved market was there's it's typically larger commercial buildings or higher funded residential buildings that are able to fund the level of sophisticated detail analysis for WFI or PHPP or the carbon impacts and things like that. And so what B Public really wanted to do was try to standardize a certain level of assumptions, and then to just sort of leverage those assumptions so to smaller residential development, so that smaller residential development or privately funded infill and so forth, which has a tremendous capacity for housing development in a sort of a social equitable way, is able to proceed using best practices of passive house and carbon sequestration. And the other one too is just really relying on the substantial amount of sort of industry knowledge that exists to date, and that's around our codes. We just got a brand new offsite construction code, which is absolutely fantastic. We have a tremendous amount of information around wood and so forth too. So so trying to really work within color within those lines while still raising the bar for performance and environmental impact. And so part of our sort of due diligence in looking at one of our processes currently is looking at manufacturing locations and approaches to manufacturing. And so looking at what are available raw material resources. And, I do believe that wood has the greatest potential for, a long-term solution for, construction and our environment. But that's certainly not to say that there are other materials out there like straw or hemp and a lot of others that have potentially a superior capacity to. But like when you look at the sheer volume of material when we try to shift over to a highly carbon sequestering building approach, then we really have to look at what is the long-term, supply chain and impacts on our environment there. And so, looking at that resource density, is one thing. So each one of these forests, like the forest in the southeast, is going to have significantly different characteristics and issues around harvesting than the lumber that we find in our in our mountain region compared to, in the Pacific Northwest. So like if you look at resource density in the mountain region, it's fairly light and so forth, but it's sort of overlaid with our ownership. It's also where we have a lot of our federal lands, and it's also where we have some of the highest fire risk. So buildup of fire fuel in those forests and there's the least amount of economically viable harvesting approaches within these areas. And part of that is because the National Forest has a lot of very clear mandates around the care and process for that extraction of resources. And we really want to support that. We don't want to go in and really start reducing those natural resources to a level that it makes it financially viable to extract forest based on the current sort of forest product demand or uses. And I think that there's the a lot of these also around sort of material density or resource density too. These are mixed hardwood sometimes as well. And so I think, when we think about the social impact and of our decisions on deciding where to extract resources and where to establish manufacturing, part of that has to do with other larger cultural issues around forest fires and forest management as well. These are really some pretty significant topics, nationally. When we look at, and so this is a great graph. It's a little bit outdated, and I bet Matt has some really actually cool, more accurate current data on it. But that if you look at the sort of the supply chain for forest product extraction, so this is our softwoods coming here, and then it's going through to lumber, paper, fuel, and then through into construction, packaging. And if you look at how much of this, and this is from 1952 to 1991, and some of the big shifts that have happened in that last 30 years have been a shift to much more advanced processes for utilizing smaller chip solid wood, like Matt was talking about. And so it's being able to pull that out of what used to be considered a fuel byproduct that was going into fuel. Now there's better long-term uses for that material in engineered wood and like fiberboard, and that's why it's so great that that Go Lab is going through that venture. And so, but part of it too is when we, and this is what Matt was talking about, like tops and limbs and things like that, was what we consider slash or residue from forest harvesting. It's 22% of that total weight is typically needing to be mitigated when it's done in forest service property. And sometimes, so when we have that being harvested on private property, that's not necessarily a mandate that needs to be done, or it can be done in lots of different ways. It can be chipped right there and mulched, or used as erosion control, also lots of different things. So but so if you just look at what our our extraction path is, so, that 78% of that material is coming out in round wood. 27% then is going on to wood products in construction, between whole wood and ply and engineered wood. This number is probably moving around quite a bit. And I did adjust these percentages based on the trends that the market was indicating for the last couple of years, a little bit. But if we look at 30% of this wood, overall wood product, is going in for fuel for burning during this industrial process, and then 22% of it is typically either having to be mitigated, like literally burning it is one of the approved approaches to it. And so we're looking at over 50% of the material is sort of a byproduct. And that's where industries like small wood fiber companies or industries really have an opportunity. And I think this is where we can, I think it requires a little bit more of a sophisticated analysis between, like, say, the use of straw compared to if we're able to pull something out of just a fuel stream and use it for a long-term increased lifespan, then what are the pros and cons there? Especially when you look at if that's not being done, the environmental impacts and economic costs to fighting fires or fire suppression and so forth too. So I think I think one of the things that we'd really like to see is that generating more economies that are able to utilize this forest material that is otherwise being burned as fuel or just mitigated slash. So that's just one of the things that we look at too when we look at what are our long range material supply chains. And so when we're developing our wall assemblies and so forth, we really are we're optimizing our assemblies in the opinion that these smaller wood fiber biomaterials are going to have the greatest positive impact compared to leveraging timber or even 1x4s or the substrate for CLT or anything like that. That really our focus should be on how small and how much lumber can we use in our residential construction. And so this is just when we're again looking at where are beneficial manufacturing points for us and the impacts for both for shipping and sort of thing. That's we'll talk about in a second, but it's BPublic is really committed to decentralized or regional manufacturing, and there's a lot of benefits to it. But you can imagine that just our projects are all across the country, and so having a single manufacturing point for construction would sort of serve everybody poorly, or it would serve one demographic well and everybody else was penalized, or it would sort of change our carbon evaluation as well. So it would be extremely variable between one project and another. And BPublic is really working on, okay, what can we standardize to a point within parameters, so that, say, our carbon footprint for every project might undulate slightly, but they would always be within our approved parameters or our stated values. And so that's so that on an individual project design basis, it's not having to be reevaluated. We're just confident it's less than or within that parameter. And it's really how we approach our building material specifications and construction and manufacturing specifications as well. So, so our largest supply and sources, paper, pulp, and craft coming through these areas. These are our cellulose manufacturing. You can see it's kind of interesting. We have these cellulose manufacturing points out in the sort of this otherwise barren manufacturing region, and it's because they are utilizing a post-consumer recycled product, and so there's actual supply chain for that material. So when it becomes more virgin use material, then they have to be closer, or they tend to be closer to their original raw material supply points.
Hey, Jonah.
Yeah.
So you asked me to give you the 5-minute warning, so this is your 5-minute warning.
Great.
Thank you.
And so it's one of the reasons why BPublic is using cellulose, just for that reason too. So the assemblies, again, like working on best practices, Passive House really does inform what we consider best practice when it comes to building physics, and and performance. Really optimizing assemblies so that they are thermally bridge free, so different connections don't have to be discounting the overall evaluated performance of the building, so a designer can work with real confidence in utilizing components or offsite assemblies and being clear that they're not going to be messing it up and so forth. So again, just sort of optimizing assemblies around best practices. And so, it's a really sort of interesting. So our assemblies are sort of embarrassingly unsophisticated in that they really do align with and comply with light wood construction approaches. And there's some really strong benefits to it. One is that, it's prescriptively exempt from special inspections, allowing for offsite construction to a point that we can actually manufacture non-project specific components, and which is an opportunity for inventory. And that's one of a big labor and social economic benefit potentials that we see from this approach, that we can standardize that demand or stabilize that demand so it's not so seasonal and so forth too. And just providing quite a bit of offsite construction, just providing and component-based construction for that matter, just providing quite a bit of stability to the residential construction market around cost, schedule, and performance. So you really can be confident that your building is going to meet passive house building requirements or standards, even if you're not going for certification, which is really. It's really fun from a design side not to worry about that stuff in a lot of ways. Engineering, it's interesting, like when we look at standardizing assemblies, one thing that's completely unstandardized is, of course, is the evaluated loads or building loads from wind, seismic, snow, all sorts of things like that. And it's also based on the shape or height of the building and so forth. And so Public's sort of versatility when it comes to structure comes from the connection between the components, and those connections are all designed to be on the exterior and utilizing, again, in really great industry standards. Simpson Tie has just such robust data and evaluation. It's really sort of a pleasure to work with it. And it also allows then inspections to take place. So it's facilitating that offsite construction process when you're doing a smaller residential project in a jurisdiction that they're not used to doing it. They're not commercial inspectors or anything like that. And so just sort of trying to minimize risk in one approach is really making sure that those structural connections are exposed. So after the prefab can be installed, the crew leaves and so forth a month later, the inspector can show up if they want to, or anything like that. So it's just really nice quality control opportunities there too. Again, there's a lot of social economic benefits to shifting to offsite construction compared to, field construction. It's just some great information from Bureau of Labor Statistics around just sort of turnover rates. Like manufacturing of durable goods has one of the longest tenure rates of any of the primary industries. And I think for very good reason. There's a lot of instability within our communities now, and so providing increased stability, I think, from an economic or job or schedule and location and so forth. Fringe benefits to that, just reducing dependence on private transportation too, really is helpful, just because otherwise if you're working in the field, you never know where you're going to be going, or you will be changing where you're going to. So this, the map on the left is just showing where Public's current projects are, and it's just sort of interesting to see over the last year where those have developed. And so those are also areas that we're going to be working on establishing manufacturing in or around those areas, and working with regional manufacturers, which is we're just really excited about. Part of that, so after all this sort of sophistication of thermally bridge-free and airtightness and building physics and so forth, that's something that sort of once we've optimized it, we don't really, it's not a primary aspect of our interface with our clientele. So we definitely work on educating them. This is the basis of these decisions. These are why we're making these decisions and so forth. But we're really trying to simplify the interface with those components so it can be more versatile, it can be iterative, it can be just helpful to the development process. So if it's not the right cost or it's not the right project, you want to know that right up at the beginning of a project and so forth. And that's where I think people are best served, is being able to evaluate building materials at this that are performing at this level early in on our project, and so that's just been it's an important aspect of our approach to the public, I think. Again, I want to give a shout out to our CEO, and she was asked to speak at this conference, and unfortunately she was traveling, and so she asked me to provide it. But I just want to give a shout out to her and all of her hard work around this stuff. I don't think we'd have any of this really together and be where we are without her support, and I just really appreciate it. And also just thanks to, we really do stand on the backs of absolutely everybody else, and just sort of being downstream from everybody. And I just can't express enough how much I appreciate the diligence and the quality of the work that that everybody's doing in the field, in particular the people, my co-presenters here. So just thank you.